Stereochemistry of organic compounds. This is again a very important branch of organic chemistry, and this topic is also belongs to the basic stereochemistry of organic compounds. Now, what we have studied yesterday in the introduction, we have studied what is meant by stereochemistry. Actually, each and every chemical molecule having a specific arrangement in the three-dimensional space, and that study, the branch of chemistry which deals with the study of arrangement of atoms or group in a space, is called stereochemistry. It was first time introduced by scientists Van 't Hoff and Liebel. They proposed a tetrahedral structure of methane molecule, and therefore that scientist Van 't Hoff also got first Nobel Prize in chemistry. Okay, this is, we have studied introduction of stereochemistry. Then we also studied what is meant by stereoisomerism. The isomers which having same molecular and structural formula but different arrangement of atoms or group in the three-dimensional space are called stereoisomers, and that concept is called stereoisomerism. We also studied just types of stereoisomerism. There are three types of stereoisomerism: optical, geometrical, and conformational isomerism. Here we have started first type, discussion of first type in detail. What is meant by optical isomerism? Now, what is the optical isomerism? The stereoisomers which having same molecular formula, same structural formula, but differ in their action on plane polarized light are called optical isomers, and that concept, that phenomena is called optical isomerism. We have studied what is meant by PPL, that is plane polar light. Then what is optical activity? Now, what is the optical activity? The property of chemical compound to rotate the plane of PPL. That chemical compound having ability to rotate the plane of PPL, and that property, that tendency is called optical activity. And such chemical compounds which can rotate the plane of PPL are called optically active compound. Okay, now there are two types of optically active compound. One is the dextroisomer and second is the leoisomer. Dextroisomer means the isomer which can rotate the plane of PPL in a clockwise direction towards the right side is called dextroisomer, while the isomer which can rotate the plane of PPL towards anti-clockwise direction, that means towards left side, is called leoisomer. And if there is an equimolar mixture of dextro and leoisomer, then it is called racemic mixture. Okay, we have studied that concept in last lecture. What is meant by optical isomerism, optical activity, optically active compound, dextroisomer, leoisomer, racemic mixture, etc. Now let us see. Now there is one question. Actually, which organic compound, which chemical compound shows optical activity? Only certain organic compound can show this property. Now question arises, which chemical compound, which organic molecule shows optical activity, which compounds are optically active? There should be some criteria. Now there are two essential conditions for optical activity. First condition, that molecule should be contain at least one chiral center. This is the first condition. And second one, that molecule should not have any elements of symmetry. Then it is optically active. These are the two conditions. आपण दोन्ही conditions one by one study करणार आहोत. But let us start with the second condition first. पहिल्यांदा मी second condition explain करतो. What is elements of symmetry? आणि मग आपण first condition बघूया. What is chiral center? Now let us start with the first condition. What is meant by elements of symmetry? There are three elements of symmetry. First one is the plane of symmetry. Then second one is the center of symmetry, second element. And third one is the alternating axis of symmetry. These are the three elements of symmetry. Now what is the statement? This is the essential condition. What is our statement? The molecule which do not have any of these element of symmetry, then it is optically active. मग ऑप्टिकली ऍक्टिव्ह असायचं असेल किंवा ऑप्टिकल ऍक्टिव्हिटी दाखवायची असेल तर मॉलिक्यूलमध्ये कोणताही एलिमेंट ऑफ सिमेट्री नकोय. Molecule should not possess any element of symmetry, then it shows optical activity. This is the condition. And suppose molecule having element of symmetry, if it having element of symmetry, then it is optically inactive. That molecule is optically inactive. It do not rotate the plane of ppl towards clockwise or anti-clockwise direction. Okay, and therefore we can say that this is the essential condition of for optical activity. That means molecule should not possess any element of symmetry. Let us see what is meant by that elements of symmetry. We will see one by one all of these three elements of symmetry. First one is the plane of symmetry. Now I will explain a simple example regarding the plane of symmetry, then we will see it's a definition or it's a description. Let us see simple example. Okay, very simple organic molecule. Yes, this is ethane molecule, CS3. I will take a simple example of ethane molecule. Carbon, first carbon attached to 3 hydrogen, CS3, then single bond, second carbon also attached to 3 hydrogen. Okay, this is the ethane molecule, CS3 ethane molecule. Now suppose just imagine there is a plane passing through the molecule. आपण काय इमॅजिन केलेलं आहे? there is a plane म्हणजे प्रतल, प्लेन म्हणजे एरोप्लेन नाहीये, प्रतल. सपोज दिस इज द प्लेन which passing through that molecule, it passing that through that molecule. Now my question for you, तुमच्यासाठी एक क्वेश्चन आहे, is it divide that molecule into two equal part? Is it divide that molecule into two equal part? That plane divides the molecule into two equal part. Okay, now I have another question. आणखी पुढचा क्वेश्चन काय असेल? Are they, means that two parts, are they mirror images of each other? Yes, that two are mirror images of each other. म्हणजे आपण हे प्रतल मिरर कन्सिडर केला तर बघा यामधला जो एक पार्ट आहे तो दुसऱ्या पार्टची मिरर इमेज आहे का? मिरर इमेज म्हणजे आरशामधील प्रतिमा. तुम्ही सर्वजण सकाळी उठल्याबरोबर पहिल्यांदा आरशामध्ये बघता. आपण ज्यावेळेस आपला चेहरा फेस आरशामध्ये बघतो, मिररमध्ये बघतो, त्यावेळेस आरशामध्ये तुमची प्रतिमा तुम्हाला कशी दिसत असते? तर आपल्या चेहऱ्यावरती जो पार्ट एकदम समोर आहे, समोरच्या बाजूला आहे, आरशामध्ये सुद्धा समोर दिसेल. फॉर एक्झाम्पल तुमचं नाक समोर आहे एकदम सगळ्या चेहऱ्यामध्ये, तर आरशामध्ये समोर दिसणार, बरोबर. त्यानंतर कान पाठीमागच्या बाजूला आहेत, कान पाठीमागे दिसतील. सिमिलर टू दॅट हिअर ऑल्सो दॅट कार्बन हा समोर आहे, आरशामध्ये पण समोर आलाय. हे हायड्रोजन बॅक साइडला आहेत, आरशामध्ये बॅक साइडला आहे. मीन्स दॅट टू आर मिरर इमेजेस ऑफ इच अदर. मग माझं कलेक्टिव्ह स्टेटमेंट काय असेल बघा? इन इथेन मॉलिक्यूल, this is the plane passing through the molecule, and that plane divides the molecule into two equal parts, and that two equal parts are mirror images of each other. That two equal parts are mirror images of each other, and this is called plane of symmetry. This is called plane of symmetry. Here ethane molecule possesses plane of symmetry, and therefore it is optically inactive. It do not show optical activity. कारण आपलं स्टेटमेंट काय आहे? मॉलिक्यूल शुड नॉट possess any element of symmetry, but ethane molecule possess element of symmetry, therefore it is optically inactive. Let us see one more example. I will take example of mesotartaric acid. The name of compound is a mesotartaric acid. Okay, compound कसा आहे बघा? CS3 COH, again carbon OH, and finally there is methyl group. Okay, now suppose this is the plane passing through the molecule. हे प्लेन त्यामधून पास होत आहे. Now here also that plane divides that molecule into two equal parts. This is the imaginary plane. This is the imaginary plane, and that imaginary plane divides that molecule into two equal parts. Now that two equal parts are also mirror images of each other. कारण बघा इथल्या बाजूला कार्बन समोर आहे, इथेही कार्बन या बाजूला येतोय. OH राईट साइडला असेल, तुमच्या मिरर मध्ये सुद्धा त्याच बाजूला आहे. मिथिल ग्रुप बॅक साइडला आहे, इथं सुद्धा मिथिल ग्रुप बॅक साइडला आहे. मीन्स दॅट टू आर मिरर इमेजेस ऑफ इच अदर. मग असं असेल तर आपण याला काय म्हणतो आहोत? यस, this again having plane of symmetry. This is the imaginary plane passing through the molecule. It divides that molecule into two equal parts, and they are mirror images of each other, and this is called plane of symmetry. Mesotartaric acid also having plane of symmetry, and therefore it is also optically inactive. It do not shows optical activity. Okay, this is just about the plane of symmetry. मग त्याला डिस्क्राइब कसं करणार? It is plane of symmetry. It is imaginary plane passing through the molecule. It is imaginary plane passing through the molecule which divides molecule into two equal parts which are mirror images of each other. Is called plane of symmetry. It is imaginary plane passing through the molecule which divides molecule into two equal parts, and they are, if they are mirror images of each other, then it is called plane of symmetry. Ethane molecule, mesotartaric acid, they possess plane of symmetry, and hence they are optically inactive. म्हणून ते optically inactive आहेत. Okay, this is the first element, plane of symmetry. Now let us see second one, center of symmetry. Okay, consider one example. I will take example of cyclic compound. Okay, this is the cyclic compound, just like benzene. Okay, now how many carbons are there in the cycle? Here, suppose this is the carbon atom number 1. Here, this is the 2, right? That's 1, 2, 3, and 4. There are 4 carbons in the cycle. We know that each carbon is attached to the 2 hydrogen. आपण हे दाखवतो किंवा नाही दाखवलं हायड्रोजन तरी चालेल. There are 2 hydrogen atom on the each carbon. इथं corner आहे. There is corner, means there is 1 carbon. Here also there is 1 carbon. That carbon having 2 hydrogen. म्हणजे स्ट्रक्चर कसं आहे? CH2, single bond CH2, CH2, and CH2. Okay, there are 4 carbons in the cycle. And this is called cyclobutane. The name of compound is the cyclobutane. Okay, this is the cyclobutane. Okay, I will make some changes. Suppose the 2 hydrogen atoms are replaced by 2 methyl group. त्यामधले 2 हायड्रोजन आपण 2 मिथिल ग्रुपना रिप्लेस करूया. सपोज या कार्बन वरचा एक आणि इथला एक. That 2 hydrogens are replaced by 2 methyl group. Now what should be the name of compound? It becomes dimethyl cyclobutane. This becomes dimethyl cyclobutane. Now, what are the positions of that carbon? Suppose this is numbered as 1, then it will be 2, then it will be 3. Okay, and this last one is the 4. That methyl groups are present on the carbon atom number 1 and 3. Therefore, that compound should be 1,3-dimethyl cyclobutane. या compoundचं नाव असेल 1,3-dimethyl cyclobutane. Okay, now there is one more extension. That 2 methyl groups are present at the opposite side of cycle. They are present at the opposite side of that ring, and hence it is called as the trans isomer. This is the geometrical isomer. This is called trans isomer, and therefore the complete name of compound is a trans 1,3-dimethyl cyclobutane. Okay, this is our compound, trans 1,3-dimethyl cyclobutane. आपण सेंटर ऑफ सिमेट्री या ठिकाणी डिस्कस करतोय, आणि या सेंटर ऑफ सिमेट्री मध्ये आपल्याला काय स्टडी करायचं आहे, तर ऍक्च्युअली हाऊ दॅट मॉलिक्युल्स हॅव्हिंग सेंटर ऑफ सिमेट्री अँड व्हाय दे आर ऑप्टिकली इनएक्टिव्ह. ओके, आपण एक्झाम्पल घेतलेलं आहे या सिटी सायक्लोब्युटेन. दॅट 2 हायड्रोजन्स आर रिप्लेस्ड बाय 2 मिथिल ग्रुप. देअरफॉर इट बिकम्स ऍक्च्युअली ट्रान्स 1,3-dimethyl cyclobutane. Okay, this is the trans 1,3-dimethyl cyclobutane. Now let us see. Suppose this is a point within molecule. यामध्ये एक पॉइंट मी कन्सिडर करतोय. दिस इज द रेड कलर पॉइंट विदिन द मॉलिक्यूल, अँड व्हेन अ स्ट्रेट लाइन इज ड्रॉन थ्रू दैट पॉइंट, सपोज दिस इज द स्ट्रेट लाइन which is drawn through that point, then we are having methyl groups on the both side. We are having identical groups from at the both side, and this is called center of symmetry. Okay, this is a point within molecule, and when a straight line is drawn through that point, we are having identical groups on the both side of that point. म्हणजे एक पॉइंट आहे त्या मॉलिक्यूल मध्ये असणारा इमॅजिनरी पॉइंट, त्यामधून आपण जर स्ट्रेट लाइन ड्रॉन केली, and if we are having identical groups on the both side of that point, then it is called center of symmetry. Suppose there is one more line, straight line. Suppose this is the another straight line. Then again we are having same atoms on the both side, 1 hydrogen and here also hydrogen on the both side of that point. Okay, this is a straight line which drawn through that point, and we are having same atoms on the both side of that point, and this is called center of symmetry. And thus trans 1,3-dimethyl cyclobutane having center of symmetry, and therefore it is optically inactive. Now what is the center of symmetry? It is a point within molecule It is a point within molecule, and when straight line is drawn through it, when straight line is drawn through it, having same atoms or group on the both side of that point, त्या पॉइंटच्या दोन्ही बाजूला लाईन वरती जर सेम ॲटम किंवा ग्रुप येत असतील, देन दॅट पॉइंट इज कॉल्ड सेंटर ऑफ सिमेट्री. मग त्या पॉइंटला आपण सेंटर ऑफ सिमेट्री असं म्हणतो. It is a point within molecule, and when straight line is drawn through it, we are having same atoms or group on the both side of that point, and this is called as the center of symmetry. Trans 1,3-dimethyl cyclobutane, it possesses center of symmetry, and therefore it is optically inactive molecule. It do not show optical activity. It cannot rotate the plane of ppl, and thus it is optically inactive. Now let us see last one, alternating axis of symmetry. Here also consider the same example. I will explain the same example. This is also trans 1,3-dimethyl cyclobutane. Okay, our previous compound trans 1,3-dimethyl cyclobutane. I will consider again one point, and there is axis. Suppose this is the axis. आपण हा एक axis consider करूया, आणि आपलं aim काय आहे? We have to rotate that molecule around that axis. या मॉलिक्यूलला आपल्याला रोटेट करायचा आहे अराउंड दॅट ऍक्सिस. हा जो ब्ल्यू कलरचा दाखवलेला आहे त्या ऍक्सिसच्या भोवती आपण या मॉलिक्यूलला रोटेट करणार आहोत. ओके, अँड इट शुड बी रोटेटेड थ्रू अन अँगल 360 अपॉन n. एवढ्या अँगल मधून रोटेट करायचा आहे. n इज एनी इंटिगर. इट मे बी 1, 2, 3 एक्सेट्रा. Suppose n is equal to 2 and we have to rotate that molecule by an angle 180 degree. 360 upon n म्हणजे त्याला 180 मधून आपण रोटेट करणार आहोत. आपलं टार्गेट लक्षात आलं का बघा. ओके, दिस इज अवर ट्रान्स 1,3-डायमिथिल सायक्लोब्युटेन. दिस इज द ऍक्सिस. हा एक ऍक्सिस आपण कन्सिडर करतोय, आणि मग आपण काय करतोय, दॅट मॉलिक्यूल शुड बी रोटेटेड अराउंड दॅट ऍक्सिस. त्या ऍक्सिसच्या भोवती आपल्याला मॉलिक्यूलला रोटेट करायचं आहे थ्रू अन अँगल 180 डिग्री. 180 डिग्री मधून आपण त्याला रोटेट करतो आहोत. मग होईल काय, इथं रोटेट केल्यानंतर काय होईल, तर इथं असणारा जो कार्बन आहे तो कार्बन कुठं जाईल, तर तो कार्बन या ठिकाणी येतोय, बरोबर. आणि इथला जो कार्बन आहे तो काय करेल, इथं जाईल 180 मधून रोटेट केल्यानंतर, अँड वी गेट द स्ट्रक्चर. सपोज दिस इज द ऍक्सिस आणि हे आपलं स्ट्रक्चर असेल. आता इथला जो कार्बन आहे इथं आला म्हणजे मिथिल ग्रुप इथला कुठं असेल, वर जाईल, बरोबर. बघा, आणि हा जो कार्बन आहे हा कार्बन इकडे गेलेला आहे, त्यामुळे आता हा मिथिल ग्रुप इथला खाली आलेला आहे. म्हणजे फक्त या मॉलिक्यूलला 180 डिग्री मधून वी हॅव रोटेटेड दॅट मॉलिक्यूल अराउंड ऍक्सिस अँड बाय अन अँगल 180 डिग्री वी गेट दिस स्ट्रक्चर. आपल्याला असं स्ट्रक्चर मिळतं. ठीक आहे. त्यानंतर नेक्स्ट स्टेप काय आहे बघा. ही पहिली स्टेप सर्वांच्या लक्षात आली का. फर्स्ट स्टेप, जस्ट दॅट मॉलिक्यूल इज रोटेटेड अराउंड द ऍक्सिस. त्या मॉलिक्यूलला एका विशिष्ट ऍक्सिस भोवती आपण रोटेट केलेला आहे 180 डिग्री एवढ्या अँगल मधून. त्यामुळं फक्त इथं काय झालेलं आहे, इथला कार्बन इथे येतोय आणि इथला कार्बन इथे येतोय. त्यामुळं मिथिल ग्रुपच्या पोझिशन सुद्धा इथं बदललेल्या आहेत बघा. ओके, नाव पुढची स्टेप काय असेल, दिस इज अवर ऍक्सिस. दिस इज अवर ऍक्सिस. मग या ऍक्सिसला परपेंडिक्युलर असणारं जे प्लेन आहे, ओके, दिस इज द प्लेन परपेंडिक्युलर टू दॅट ऍक्सिस. नाव दॅट मॉलिक्यूल इज रिफ्लेक्टेड. दॅट मॉलिक्यूल इज रिफ्लेक्टेड म्हणजे हा जो मॉलिक्यूल आहे याला आपण रिफ्लेक्ट करणार आहोत अक्रॉस द प्लेन परपेंडिक्युलर टू दॅट ऍक्सिस. त्या ऍक्सिसला परपेंडिक्युलर असणारं जे प्लेन आहे त्या प्लेन मध्ये त्याचं रिफ्लेक्शन आपल्याला बघायचं आहे. म्हणजे तुम्हाला एक साधं उदाहरण सांगतो म्हणजे तुमच्या लक्षात येईल. सपोज 4 लेग असणारं एखादं बेड तुम्ही कन्सिडर करा. 4 पाय असणारं बेड कन्सिडर करा. आपण त्याला सिंपल एक हे 4 लेग्स आहेत, 4 पाय आहेत आणि ते बेड एक आहे. आपण त्याला काय कॉट असं म्हणूया किंवा आणखीन काही शब्द असतील. तर त्याच्या खाली पूर्ण मिरर आहे, त्याच्या खाली पूर्ण आरसा आहे. तर त्या बेडची म्हणजे 4 पाय असणारा जो बेड आहे त्याची त्या आरशामध्ये प्रतिमा कशी दिसेल बघा. दिस इज अवर ऍक्सिस. या ऍक्सिसला परपेंडिक्युलर असणार हे प्लेन म्हणजे हा 4 पाय असणार बेड कन्सिडर करूया आणि त्या बेडच्या खाली पूर्ण आरसा ठेवलेला आहे. पूर्ण खाली जमिनीवरती आरसा आहे, त्या आरशावरती बेड आहे. मग त्या आरशामध्ये त्या बेडची प्रतिमा कशी दिसेल ते आपण बघूया. तर बघा, हा मिथिल ग्रुप खालच्या बाजूला आहे, बेडमध्ये कुठं दिसेल, वरच्या बाजूला. हा मिथिल ग्रुप आरशापासून दूर आहे, बरोबर. आरशामध्ये सुद्धा तो काय होईल, त्याच्यापासून दूर जाईल. म्हणजे आपल्याला बघा या पद्धतीची प्रतिमा मिळते. हे जे 2 मिथिल ग्रुप्स आहेत म्हणजे हा खाली असल्यामुळे इथं खाली मिळतोय, हा मिथिल ग्रुप इट इज अवे, हा इथं अवे मिळतोय आपल्याला हा मिथिल ग्रुप. ओके, लाईक दॅट. अँड दिस इज जस्ट रिफ्लेक्शन. हे त्याचं रिफ्लेक्शन आहे. आता तुम्ही बघा, हे जे रिफ्लेक्शन आता आपण बघितलं, इज इट सिमिलर लाईक ओरिजिनल? ते ओरिजिनल सारखं आहे का? इज इट सिमिलर लाईक ओरिजिनल? येस, इट इज सिमिलर टू द ओरिजिनल. अँड दिस इज कॉल्ड अल्टरनेटिंग ऍक्सिस ऑफ सिमेट्री. याला म्हणायचं अल्टरनेटिंग ऍक्सिस ऑफ सिमेट्री. मग अल्टरनेटिंग ऍक्सिस ऑफ सिमेट्री म्हणजे काय? when molecule is rotated around the axis by an angle 360 upon n and then reflected, the molecule is rotated around the axis by an angle 360 upon n and then second step काय आहे? and then reflected across the plane perpendicular to that axis, we get the structure like original. आपल्याला पहिल्यासारखं स्ट्रक्चर मिळतं. and this is called alternating axis of symmetry. Now trans 1,3 dimethyl cyclobutane also possess alternating axis of symmetry and therefore it is optically inactive. It is optically inactive. मग आपला क्वेश्चन काय असेल? yes, there are three elements of symmetry: plane of symmetry, then center of symmetry, and there is alternating axis of symmetry. And if molecule possess any element of symmetry, then that molecules are optically inactive. They do not show optical activity. Okay, this is the essential condition. मग जर ऑप्टिकल ऍक्टिव्हिटी दाखवायची असेल तर काय असायला पाहिजे? that molecule should not possess any element of symmetry, then it is optically active. Okay, this is actually second essential condition. Now let us see first essential condition for optical activity. What is meant by chiral center? आपण यामधली पहिली महत्वाची कंडिशन बघूया. what is chiral center? Molecule should be possess at least one chiral center, then it is optically active. Let us see simple example of organic compound. Okay, this is the example of organic compound. Here, that central carbon, suppose I will make star, this is the lactic acid, actually name of compound is lactic acid. I will make star to that central carbon. Now this central carbon is attached to the one OH group, another one is the methyl group, third one is the hydrogen, and fourth one is the COOH. Okay, thus there are four different atoms or group. In this case, there are four different atoms or group. Means that central carbon atom is attached to the four different atoms or group, and that carbon is called chiral center. The carbon atom which is attached to the four different atoms or group is called chiral carbon or chiral center, किंवा त्याला आपण asymmetric carbon atom असंही म्हणतो. It is also known as asymmetric carbon atom किंवा chiral carbon किंवा chiral center. Okay, this is just about the what is meant by asymmetric carbon atom, then chiral carbon or chiral center. कसं डिफाइन करता येईल? The carbon atom which is attached to the four different atoms or group is called chiral center, chiral carbon or asymmetric carbon atom. What's about this carbon? हा जो मिथिल ग्रुप मधला कार्बन आहे हा chiral carbon आहे का? That carbon is attached to the three hydrogen. Three hydrogen means they are not different and therefore it is not chiral. Here that carbon is attached to the four different atoms or group. म्हणून हा मात्र chiral carbon आहे, त्याला आपण chiral carbon असं म्हणतो. ओके, and thus this is about the chiral carbon. मग आपलं मगाशी मी काय सांगितलेलं आहे? molecule should contain at least one chiral carbon, then it shows optical activity. This is the essential condition. The presence of chiral carbon is one of the essential condition for optical activity. The molecule which possess chiral carbon, मी काय सांगतो हे स्टेटमेंट खूप महत्वाचं आहे. द मॉलिक्यूल विच possess chiral carbon and do not having any element of symmetry is called chiral molecule. Chiral molecule is different term than chiral carbon. Chiral molecule is different term. molecule हा त्या molecule साठी कंपाऊंड साठीचा टर्म आहे आणि chiral center कोणाला म्हणतोय आपण? पर्टिक्युलर कार्बन ऍटमला. That carbon atom which is attached to the four different atoms or group is called chiral center. आणि chiral molecule कोणाला म्हणायचं? The molecule which having chiral center and do not having any element of symmetry is called chiral molecule. Okay, and that chiral molecules are optically active because they possess both the condition. They do not having any element of symmetry and also there is a chiral center, and therefore they are optically active. ते ऑप्टिकली ऍक्टिव्ह असतात. फॉर एक्झाम्पल लॅक्टिक ऍसिडचं घेऊया. लॅक्टिक ऍसिड मध्ये एक कायरल कार्बन आहे आणि त्यामध्ये कोणताही एलिमेंट ऑफ सिमेट्री नाहीये. जर आपण त्यामधून सपोज असं प्लेन पास केलं तर हे प्लेन पास केलं, डू नॉट डिवाइड दॅट मॉलिक्यूल इनटू टू इक्वल पार्ट, म्हणजे तिथं प्लेन ऑफ सिमेट्री नाहीये. सिमिलरली इट डू नॉट हॅव्हिंग सेंटर ऑफ सिमेट्री, देयर इज नो अल्टरनेटिंग ऍक्सिस ऑफ सिमेट्री. Therefore, lactic acid do not having any element of symmetry. Also, there is one chiral center, and therefore it is chiral molecule, and it is optically active compound. Lactic acid is the optically active compound. Okay, and this is the chiral molecule. Okay, this is very very important term. आपण काय स्टडी केलं आता? What is elements of symmetry? महत्वाचं elements of symmetry. ठीक आहे. त्यानंतर chiral center किंवा asymmetric carbon atom म्हणजे काय? बरोबर. जो the carbon atom which is attached to the 4 different atoms or group is called chiral center. ठीक आहे. त्यानंतर chiral molecule कोणाला म्हणतोय? The molecule which having chiral center but do not having any element of symmetry is chiral molecule, and it is optically active. For example, lactic acid. Okay, now let us see next term, a chiral molecule. This is also important term. I will explain one example. Okay, again same example of mesotartaric acid. मगाशी आपण बघितलं होतं. CH3, CHOH, CHOH, CH3. The name of compound is a mesotartaric acid. Okay. Now my first question is आता आपल्याला काय बघायचं आहे? पहिल्यांदा ऑप्टिकल ऍक्टिव्हिटी बघायची असेल, यामधल्या ज्या 2 कंडिशन्स आहेत. विच कंडिशन्स आर देअर? वन, इट शुड हॅव कायरल सेंटर, इट शुड नॉट हॅव एनी एलिमेंट ऑफ सिमेट्री. आपण पहिली कंडिशन बघूया. इज इट हॅव्हिंग कायरल सेंटर? आपण पहिल्या कार्बन कडे येऊया. हा पहिला कार्बन, it is attached to the 3 hydrogen, therefore it is not chiral. What's about the second? That second carbon is attached to the 1 OH, then second methyl group, third hydrogen, आणि चौथा हा पूर्ण ग्रुप आहे. बरोबर. 1 methyl group is there, 1 OH is there, 1 hydrogen is there, and fourth whole this group is. Means that carbon is attached to the 4 different atoms or group, and hence that carbon is a chiral in nature. म्हणजे हा chiral carbon आहे. Okay, what's about the next? It is also attached to the 1 OH, 1 methyl, third hydrogen, and 4 this group, and therefore this carbon is also attached to the 4 different atoms or group, hence it is also chiral in nature. तो सुद्धा chiral center आहे, chiral carbon आहे, asymmetric carbon atom आहे. म्हणजे माझं पहिलं स्टेटमेंट काय असेल? Yes, that mesotartaric acid having 2 chiral center. It having 2 chiral center. Okay, but suppose is it having any element of symmetry? Suppose this is the plane passing through the molecule. Now is it divide that molecule into 2 equal part? हे प्रतल मी आता दाखवलेलं हे जे प्रतल आहे, is it divide that molecule into 2 equal part? Yes, it divide that molecule into 2 equal part. Now are they mirror images of each other? हे 2 पार्ट एकमेकाचे मिरर इमेजेस आहेत का? Yes, that 2 parts are mirror images of each other. हे एकमेकाचे आरशामधील प्रतिमा आहेत, and therefore there is a plane of symmetry. Means that mesotartaric acid having plane of symmetry, and hence that molecule is optically inactive, and such molecule is called a chiral molecule. That molecule having chiral center, it having chiral center, but there is a plane of symmetry. There is an element of symmetry, and such molecule is called a chiral molecule. अशा molecule आपण a chiral molecule असं म्हणतो. The molecule which having chiral center, but there is an element of symmetry. That molecule is a chiral, and such molecules are optically inactive. They are not optically active, inactive. Okay, and thus mesotartaric acid is optically inactive. It is a chiral molecule because there are 2 chiral center, but there is a plane of symmetry. त्यामध्ये plane of symmetry आहे, and hence it is optically inactive, and it is a chiral molecule. Okay, this is again important term, a chiral molecule, and thus that is optically inactive. मग आपण खूप महत्वाच्या 1-2-3 टर्म आता स्टडी केला. Actually there are 2 essential conditions for optical activity. पहिली कंडिशन कोणती? That molecule should be contain chiral center. It should be contain chiral carbon, किंवा त्यालाच आपण asymmetric carbon atom असंही म्हणतो. Okay, first term, that carbon atom which is attached to the 4 different atoms or group is called chiral carbon. त्यानंतर आपण सेकंड टर्म काय बघितले? एलिमेंट्स ऑफ सिमेट्री. There are 3 elements of symmetry: plane of symmetry, center of symmetry, alternating axis of symmetry. and molecule should not have any element of symmetry, then it is optically active. And if it have element of symmetry, then it is optically inactive. Okay, मग आपण यामध्ये कायरल मॉलिक्यूल हा कन्सेप्ट स्टडी केला. कायरल मॉलिक्यूल आपण कोणाला म्हणतो? द मॉलिक्यूल विच हॅव्हिंग कायरल सेंटर and do not having any element of symmetry is called chiral molecule. The molecule which having chiral center and do not having any element of symmetry is called chiral molecule and it is optically active compound. हे compounds optically active असतात. त्याचबरोबर आपण अकायरल मॉलिक्यूल हाई टर्म बघितलं. फॉर एक्झाम्पल मेसोटार्टरिक ऍसिड इट हॅव्हिंग टू कायरल सेंटर बट देर इज अ प्लेन ऑफ सिमेट्री. दॅट मॉलिक्यूल इज अकायरल अँड इट इज ऑप्टिकली इनऍक्टिव्ह. ओके, दिस आर व्हेरी व्हेरी इम्पॉर्टंट टर्म्स. या खूप महत्वाच्या अशा टर्म्स आहेत, त्यावरती थोडंसं व्यवस्थित कॉन्सन्ट्रेट करा. पण कन्सेप्ट हा जर व्यवस्थित तुम्हाला समजला म्हणजे व्हॉट इज एलिमेंट्स ऑफ सिमेट्री, व्हॉट इज कायरल कार्बन, व्हॉट इज कायरल मॉलिक्यूल, व्हॉट इज अकायरल मॉलिक्यूल, मग तुम्हाला इथून पुढे स्टेरिओ केमिस्ट्री अजिबात अवघड जाणार नाहीये. कारण दिस इज व्हेरी व्हेरी बेसिक कन्सेप्ट रिगार्डिंग द ऑप्टिकल ऍक्टिव्हिटी, ऑप्टिकल आयसोमरिझम. आणि म्हणून ही टर्म्स खूप महत्वाच्या आहेत.